Hi, I'm Mr. V. Our geometry text this year is Illustrative Mathematics. We're in Unit 5, which is about solid geometry, and this is Lesson 17 on volume and density. By the end of the lesson, you should be able to say, I can solve problems with volume and density, and I know the density of an object is the ratio between its mass and its volume. So the first question I have for you is, which is heavier, 1,000 kilograms of feathers or 1,000 kilograms of steel? And the second question is a trick question. It says, which has more mass, 1,000 kilograms of feathers or 1,000 kilograms of steel? And explain your reasoning. Both of these questions are ones that I might ask a Weeblos Cub Scout because they like these silly kind of joke type things. Which weighs more, a pound of feathers or a pound of steel? Well, they're the same. Same with a kilogram. Kilogram is a unit measure of weight. And when we talk about mass, mass is the weight. So mass, they both have the same density. And that was a big deal. Mass is the, when we talk about mass, we talk about the weight. This table here should make its way into your reference chart. Density is equal to the mass divided by the volume. And there's a very interesting little video here about Archimedes and the Archimedean principle, how he tried to figure out whether or not the crown was really gold, and really what this story was about historically in the Syracusia. If you've never heard of it, it's worth watching. It's only 5 or 6 minutes. For our questions, we're going to look at this problem. First of all, you need to know that the cubic meter is 1 cubic meter. A meter is, if I take my chest and I go out to the end of my fingertips, that's how long a meter is. And a cubic meter would be this long, this wide, and this high. So that's about how this long, this wide, and this high. How many cubic centimeters is it? It's 1,000,000. That is, there's 100 centimeters in a meter. So 100 in this direction, 100 in this direction, 100 in that direction. It's 1,000,000 cubic meters. We're going to have to use that to convert our units here in a minute. The second question is, pay close attention to the here. Let me just show you what this looks like on our screen. Feathers in a pillow have 59 grams. That's the mass. And we want to change that to kilograms. We want to change find the volume and change that to meters cubed from cubic centimeters. And then we want to find the density. So let's do each of these. First of all, we're told it's 59 grams. That number goes in here. To change that to kilograms, I have 1 kilogram for every 1,000 grams. And I can set this equal to X number of kilograms, which is the number we're looking for, it goes here, for every 59 grams. And you'll notice that this is 59 thousandths, or if I move the decimal place tenths, hundredths, and thousandths, I end up with 0.059 is my kilograms. To find out the volume, we're going to use the volume formula for a prism, which is the length times the width, that's the area of my base, times the height. And when I substitute the values of 51 times 66 times 7, I get 23562. This is centimeters times centimeters times centimeters, so my units is centimeters cubed. Now, to convert this number to meters cubed, I know that there's 1 meter cubed for every 1,000,000 centimeters cubed. And so if I substitute the values here, we could call this y, since we've already used x. Meters cubed is for every 2,356, 23,562 centimeters cubed. Well, this is going to be 23,562 divided by 1,000,000. Or I'm going to move this 6 places. 1, 2, 3, 4, 5, 6. And I get 0.023562. So take your mass and you divide it by the volume. We're using kilograms per meters cubed. And when you do this calculation, you end up with about 2.5. So my density of feathers is about 2.5 kilograms per cubic meter. Now, a meter cubed is like my distance of my arm, distance of my arm, distance of my arm going down. That would be a meter cubed. How much is 2.5 kilograms? That's about 5.5 pounds. I could lift this. I'm okay with that. I could lift that. Let's do the same thing though with the volume and the density of this pyramid, which is made out of steel. So a pyramid, the volume of a pyramid is equal to 1/3 the area of the base times its height. It's a square base. We're told it's 20 centimeters and its height is 28. So it's 1/3 times 20 times 20 times 28. This is going to be my volume in cubic centimeters. So we do 1/3 times 20 times 20 times 28. I get 3733.3. 3733. And you can plug this into the Desmos, and it'll give you feedback if your number is correct or not. What is the kilograms? Well, let's read with understanding. Right there it is. We were told that it's 30. Now we need to find the volume in cubic meters. Again, 1 meter cubed is equal to 1 million centimeters cubed. So how many meters cubed, we don't know, let's call it X, is 3,733. It's 3,733 divided by a million. I'm going to move this 6 places. 1, 2, 3, 4, 5, 6. I get 0.003733. And again, I'm going to take the mass divided by the volume to get the density. Density is the mass divided by the volume. So if I do this, I have 30 divided by 3,733. I get, I divided by 0.003733. What? It's 8,036 kilograms. That's like 16,000 pounds. It's like 8 tons. This is huge for this volume of cubic centimeter. For this volume, this is a really tiny volume of cubic meters. Whoa, it's really heavy stuff. So let's go to the next problem, which was we found the density to be 2.5 kilograms per cubic meter. What is the volume? So we're looking for this guy of 1,000 kilograms. If you cross multiply, you end up with X is equal to 400 cubic meters. Now, what does that look like? How much is 400 cubic meters? Would this fit into your room? Would it fit into a gymnasium? Would it fit into the back of a truck? Would it fit in a bread box? When we do the second one, 8,036 kilograms per cubic meter. If we had 1,000 kilograms of steel, how dense is that going to be? What is this going to be? Because this is over 1, and we want to know what the cubic meters would be. If you do this calculation here, our value is going to be 0.124. It's about 1/8 of a cubic meter. And how much is 1/8 of a cubic meter? I told you that a cubic meter is going to be my length here, sideways, going across, and going down. Let's look at what this is for a picture of this. I actually have a picture of this in my Desmos. Here's what 1 cubic meter looks like. So if you take one of these boxes, this is 1/8, this is about 0.125 instead of 0.124. That's about what 1,000 kilograms of steel would look like. 1,000 kilograms is like 2,000 pounds. There's no way I could lift that. It could fit in the truck. Hopefully I got big tires on the truck that hold that kind of weight. Now to get to 4,000 kilograms of feathers, to get to 400 cubic meters, these are movers. They're trying to show you how to move. This is 10 cubic meters. Can you imagine 40 of these? I know it's not going to fit in my room. I don't think it'll fit in yours either. It might not even fit in the gym. I don't know, but that's a lot of feathers. We'll find out. Anyway. I have a couple of extra problems to go through. One is this one of paper. If you had a chance to get $1 million for $50. You give $50, you get $1 million back. Would you do it? The deal is that you have to carry them out on your back in $1 bills in one take. Would they fit? And so basically you have to figure out what is the volume going to be of $1 million? And what is the weight going to be of $1 million? First of all, it's going to be about the size of a cubic meter. It's going to be huge. And it's going to weigh like 2 tons. There's no way this would work. But you do the calculation, and this is a kind of a fun problem. There's also this problem here, which is kind of interesting. This is a fish tank that's in the Radisson Blu Hotel in Berlin. They fill it with fish. It goes all the way down to the ground. Whoa. First of all, how much weight is that water? What size glass do they have to have? How do they keep it from doing? What do they do for the hydraulic pressure on those fish? How do those fish survive? How many fish can they fit into it? That's kind of thing. And that's really what the problem was that we're going through here. Aquarium manager drew a blueprint. This is his blueprint. For the best average density of the fish going into the tank is 16 fish per 100 gallons of water. That would be the best density. 16 fish per 100 gallons. So we need to figure out how much gallons of water this fish would hold. You're going to stand up in the middle and be able to look at the fish. That's what the idea is behind this. And they have 275 fish. So the question isn't how many fish you're going to need. It's going to be how many should you add to the 275 or how many should you remove. And when you put your answer in here, it'll tell you if it's correct or not. So let's just work through this problem. It will not take too long, I don't think. I know that we've done quite a bit on this video already. So I have this cylinder inside a cylinder. The outer cylinder has a radius. They both have a height of 4. And the big one has a radius of 5. The small one, which we're going to cut out the middle where the person's going to stand up, it has a height of 4. And it has a radius of this one of 2. Now, we take the volume of the one and we subtract the volume of the other. That will give us the volume of the water. We know that the fish density is 16 over 100. This is fish per gallon. So we need to figure out how many cubic feet there are, and then we need to figure out how many gallons there are. So let's do that. The volume of a cylinder is equal to the area of the base times the height, which is pi r squared times the height. So I'll take the volume of this one, which is pi times 5 squared times 4, minus pi times 2 squared times 4. This is 5 times 5 is 25. 4 quarters is 100. This is 100 pi. Minus, this is 4 times 4 is 16 pi. So I end up with 84 pi cubic feet. Now, I need to change this over to gallons because my density over here is in gallons. If you look it up on Google, you'll find that there are 7.48 gallons per cubic foot. And I can set a proportion here. I've got my cubic foot. This is foot cubed. This is the same as cubic foot. This is 84 pi. And I want to know what is the volume in gallons that's going to be. So this will be X. When I cross multiply, I do 84 pi times 7.48. I get 1,974 gallons. Whoa. Well, let's do this over here. How many fish do we need? We'll call this Y, fish, for every 1,974 over this way. And I'll do the calculation. 16 times 1,974 divided by 100. That's going to be that's 200. I need to divide by 100. It's going to be 316. 316 fish is what I need. Or is it 316? Let me just check this out. What if I did instead of, I did 95. I should do 94. 315.84. 315.84. This means that I need to take, you can't have part of a fish. So I'm going to I'm going to truncate this to 315 fish. Well, 315 fish is what I need to make this optimum. And we're told in the storyline from this problem that we have 275 fish. So 275 fish. When I take away the 275, I need to have 40 more fish. So I need 40 more. It'll be a plus 40. And you put that into the Desmos, and it should give me a correct answer. It should say yes. It says it's correct. Good. Okay. Um, in this lesson, we used density. And what are some things with very high density in the world? Well, there's bowling ball, brick, very lightweight balsa wood, styrofoam. How about think of something you can tell me is more or less dense than air? Is there anything that you could think of? Well, helium. Helium rises. CO2 is heavier. It sinks. What other kind of densities could there be? You could have things like a population density or a caloric density or any kind of ratio. There's a summary page here for you to watch, and then there's a shutdown. There's also a bonus question on page 19. I tell you about a problem that I ran into in college. So anyway, density, it's equal to the mass divided by the volume.